Hello, kids. This is Sir Mag. Today, our topic is going to be DC motor. Wow, the question is, what is DC motor? A machine that converts electrical energy into kinetic energy. Let's talk about the working principle then. Basically, its working principle is force on a current carrying conductor placed in a magnetic field. For all those of you who does not know what is a force on a current carrying conductor, go review my video before this so that you can understand the concept clearly. In a DC motor, let's look at the perfect sample of a DC motor. In a DC motor, there are two permanent magnets. One's north pole and the other one's south pole. This permanent magnet is to provide a strong magnetic field that would exert a force on the coil. There's an armature, that is a coil of wire. This armature carries the current and it experiences force and hence rotates between the poles about the axis. Basically, the split ring commutators flips the direction of the current in the coil when it crosses the vertical position. These split ring commutators are connected with carbon brushes. These carbon brushes gives a smooth contact to reduce friction between the external circuit and the split rings. When the current is being supplied from one side, the armature experiences a force that can be determined with the help of Fleming left-hand rule. For the Fleming left-hand rule, pause the video and determine the direction of the force on the left side of the armature as well as on the right side of the armature. Consider the current being supplied as shown in the diagram. Let's figure it out. Okay, so on the left hand side, the force is in the upward direction, and on the right hand side, the force is on the downward direction. These two forces will cause the coil to rotate and hence there will be a turning effect. What happens when the armature rotates? Now there's a problem. There's a point where we need to flip the direction of the current so that the coil can experience the same flow of current throughout the 360 turn. For that reason, we use a device that is known as split rings commutators. Let's move forward. Let's see the top view. Okay, so while we are watching the top view, let's name these four sides A, B, C, and D. For the side AB, the current is going upwards. When we use the Fleming left-hand rule, we can clearly state that the force will be downwards. For the side CD, the force will be upwards. This will show a turning effect that will be in the clockwise direction. After a 180-degree turn, now the side CD is on the left-hand side and the side AB is on the right-hand side. To keep the direction of the current flowing in the specific way, we need to use these split ring commutators. These split ring commutators are connected with carbon brushes, and we know why the carbon brushes are used to reduce the friction and creates a sliding contact. Okay, so let's see the front view. Front view for initial position is as follows, and after 180 degrees of rotation, the view would be somewhat like this. These forces and the direction can be determined with the help of Fleming's left-hand rule. The question is, how to increase the force output of a DC motor? For increasing the output force, we can do three different things. First, we can use a stronger magnet. We do not need to take the magnet to the gym, just rather use a magnet that has a strong magnetism. The second is use more current in the coil. If you increase the current, there will be more powerful output of the current supply. For that, you can use a powerful battery. Third, you can increase the number of turns in the coil. These three things helps to increase the force output of a DC motor.